And what we are going to do now is to see how we can use this toolbox to try to visualize RFM models into Grasshopper and Rhino. And in particular, it will be very interesting, this option that we have to extrude members or beam objects as 3D geometry into Rhino. But let's go step by step. So you can see that I have here my concrete building that we were using in the first chapter, but I have modified just one thing, which is that this member here is now like with a curved shape, and this will help us later on with the explanation of the extrusion of member elements. Okay, so this is my Grasshopper window, of course, and we have to start by importing our data in Grasshopper with the getData component. So what do we need actually? We need, of course, the members, we need also the surfaces of our model, and also we need the cross sections, since we want the shape of the cross sections to be able to extrude our beam elements later on. So let's get this data into Grasshopper. Now we can see that we have our members and surfaces here, like that, and we can very quickly cast our member elements into curves and our surfaces, RFEM surfaces into surfaces here. Okay, so there we go. And this is our building, and of course looks very nice with the openings, even the curved walls are here, so it looks really nice. But of course it would be quite more interesting if we could draw our members here instead of as line elements or curves as 3D shapes, and that's what we are going to do now. But let me just give 1 second, because of course in order to extrude those elements we need the shapes of our cross sections. So one way to do that would be to disassemble our cross sections here. There we go. And of course this has to be disassembled, and we just need to plug our cross sections here, and we have this interesting parameter here, which is shape, which actually give us the shape of our cross sections, and it locates them into the point or over the point 0, 0. So these are basically the cross sections of the member elements that we have defined in RFEM, and we can use them to manually extrude our members here through these baselines. But I think there is a much more interesting approach in the plugin, which is to use this component that I have specifically created for that, which is extrude members. So let's get into the canvas, and we can see 2 things. First, that we can either choose draw these items either as nerves or as meshes, and also we can see that we have to provide both the members and the cross sections, of course, so that we can properly extrude those these elements. So let's provide the members and the cross sections that we imported from RFEM. So once we do that, we can see that it was quite fast, and now and now we can see our member elements here with the proper cross section, with the proper geometry. Even this curved member is perfectly drawn here, and actually this looks pretty nice with the bracing as well. So this is really fantastic, I think. There you go, with our 3D shapes. And of course the concrete columns were also imported without any problem. So now this is our 3D model, and yeah, we can have a look which options we have here. So this parameter length segment, this also in the case of nerves, it applies just to the curved members, because of course what this component is doing is to, let's say, loft series of cross sections which are located along this curve. So the bigger this parameter is, means the bigger the segments are. So it locates fewer cross sections. So if we make this bigger, like 2 or 3, we can see that now we have just one segment, because of course it's almost as long as this as the baseline. So this could be a straight line, and the smaller we make this number, the more accurate would be the geometry. So this is of course regarding just nerves, but if we go to the option of meshes, we can see that now we have our members here extruded as meshes, in case that perhaps, I don't know, your model might be lighter, or you might work with meshes more comfortable than with NURB geometries. I don't know, that's your choice. But anyway, there we go. So this is our meshes rather, and we have these two options now. We can either decide faces by cross section, that if you take a look here, you can see that in its, let's say, face of the cross section, there are now, it's divided into two mesh faces. But if we make this parameter bigger, like, I don't know, for instance 4 or 5, you can see how now we have more faces. And of course, this goes in one direction, but we can also control the subdivisions of our mesh with the other parameter, which is length by segment. And by the way, if you do double click into this slider, you get this pop-up window here, and you can manually specify the value. So let's say that we want segments just 0.5 meter long. And if we do that, we can see how now we have more subdivisions, and probably this will be interesting for our curved member here. Yes, here we go. And we can see that now it has a higher resolution than before. Okay, so basically these are our options to extrude member elements as 3D shapes in Grasshopper. And I think it could be really interesting to try to bake this geometry into Rhino to see how this 3D model looks like using the visualization options that Rhino offers. So let's try to bake this geometry. There you go. We can hide it. So there we go. And this, of course, is the wireframe mode. But I think that if we want to get a visualization, of course, we could render the model. But just to do a very quick visualization, let's get the Arctic mode. So I just have to right click into the viewport bar here, and let's get the Arctic mode running. And we have to hide our Grasshopper parameters here, and there we go. So we created this with meshes, and it looks really nice, I think. Well, perhaps these curved walls need a bit of post-processing, but besides that, we can take a closer look, and we can see how nice our, and actually I'm going to make this bigger. We can see how nice our steel profiles look like here, right? Because we have the bracing elements, we have these steel profiles perfectly extruded into 3D. We have our curved beam. You can see this transition, how smooth it looks like, and I think this is actually a great result for our 3D visualization. There you go.